This video is for Chapter 6, Section 1. It's all about special quadrilaterals. Before we go into what the special quadrilaterals are, we should at least define real quickly that quadrilaterals are any shape with exactly 4 sides. This does not have to be convex or concave or have anything special to it. If it has 4 sides, we call that a quadrilateral. What we're going to look at is certain quadrilaterals that have characteristics to give it a name, a more common name that we've heard of that we need to define. So, the first set of quadrilaterals comes in a family. And in this family, there's one overlining defining characteristic. So, here is the first family. Starting off with the parent of the family right here. This shape has 2 sets of parallel sides. Now, even though it is not marked, the other 3 shapes also have 2 sets of parallel sides. We may spend time in class proving this and showing why. But to start, we're going to define the shape that has 2 pairs of parallel sides. We call this a parallelogram. Both pairs of opposite sides are parallel. Not one pair, but 2 pairs. You have to have 2 pairs of parallel sides, and this is a parallelogram. We do have a mini symbol for it, just in case we were writing and we wanted to put the shape of a triangle for triangle. We do have the parallelogram symbol. This is the only shape that has a symbol for it. Okay. Now, this is a special quadrilateral. It is a 4-sided figure with one specific characteristic. Now, the parallelogram itself has its own family. It has parallelograms that are special. The first special parallelogram is a parallelogram in which all 4 sides are exactly the same. This is what we call a rhombus. A rhombus is defined as an equilateral quadrilateral. Now, on the screen I have a parallelogram with 4 congruent sides. So there are 2 ways for us to understand rhombus. 1, it is a parallelogram with all 4 sides congruent. Or it turns out that we can eventually prove that as long as you are told all 4 sides are congruent, we can call it a rhombus, which then lets us know it is a parallelogram. I would write down equilateral quadrilateral. That's the 2-word definition for rhombus. Equilateral quadrilateral. So then you have the other relative. One side of the family from parallelograms are equilateral. The other side of the family has all right angles. Since a quadrilateral adds up to 360 degrees, the angles, you divide that by 4 and they would all be 90. This is equiangular. So we like to call this a rectangle, a parallelogram with 4 right angles. That is the definition for rectangle. The 2-word definition is equiangular quadrilateral. Parallelogram, rhombus, equilateral quadrilateral, rectangle, equiangular quadrilateral. And then finally, the rock star of the parallelogram family, the square. Square is very unique because it actually has the most amount of characteristics that have to be satisfied before we can call it a square. It has to be a parallelogram. It has to be equilateral, which means it's a rhombus. And it has to have 4 right angles, which means it's a rectangle. So this is a parallelogram with 4 congruent sides and 4 right angles. The 2-word definition that you should write down, this is a regular quadrilateral. Regular means equilateral and equiangular. Now, it's important to also write down, a rhombus is a parallelogram. A square is a parallelogram. A square is a rhombus. A square is a rectangle. A parallelogram is sometimes a rhombus, not always. A rhombus is always a parallelogram. All squares are parallelograms. Not all parallelograms are squares. So it really depends on what they tell us first. If I tell you it's a parallelogram, that's all we can conclude. But if I tell you it's a rectangle, we can say, well, then I know it's a parallelogram and it might be a square. So we have to understand how we can move through this family. So the parallelogram family, two pairs of parallel sides. Let's go to the next family, which is going to be no parallel sides. Now this would just be any regular quadrilateral, so we had to give it something special. Two pairs of congruent sides, but no parallel sides. So this would be a kite. A kite is a quadrilateral with two pairs of adjacent sides congruent, so we have to be careful. Rectangle has two pairs of congruent sides, but these have to be adjacent. That's the key word. Adjacent sides congruent. No opposite sides congruent, no parallel lines. I like to think of a kite as being an isosceles triangle put on top of another isosceles triangle. Isosceles on top, isosceles on the bottom. Now, it cannot have all four sides congruent. That would be a rhombus. So it has to have two pairs of adjacent sides congruent and nothing else. Now, this is not the only kite. There is one kind of funky special kite out there, which I'll draw here. And that is the kite that is concave. This still technically meets the definition of a kite, and we must call it a kite, but this is a special kite, and because it's concave versus convex, this one has a special name, deltoid. This might be kind of a bonus for this level to know that name, deltoid. Don't confuse it for any concave quadrilateral. It has to be a concave kite. So we've looked at two pairs of parallel sides, we've looked at no parallel sides. The last family is one pair of parallel sides. And that one pair of parallel sides is the trapezoid family. Simply defined as a quadrilateral with one pair of parallel sides. The other pair of sides is whatever we want. Now, within the trapezoid family, there is also one special trapezoid. That is the trapezoid where one pair of parallel sides and the non-parallel sides are congruent. This is the isosceles trapezoid. The best way to understand why this is called an isosceles trapezoid is to picture an isosceles triangle in which someone cut the top off with a line parallel to the base. So we've taken an isosceles triangle, chopped the top off, and we have ourselves an isosceles trapezoid. There will be similar characteristics between an isosceles triangle and trapezoid. So, one pair of parallel sides and the non-parallel sides are congruent. One pair parallel, non-parallel sides are congruent. All right. So that brings me to my final diagram of our three different types of quadrilaterals. We have no parallel sides, where you could be a kite, a deltoid, or any basic quadrilateral out there. There's one pair of parallel sides, the trapezoid, which also has the special isosceles trapezoid, and the two pairs of parallel sides, which is the parallelogram family. The reason I put this diagram in is just to understand that you can, if you are moving up the diagram, the answer would be always. A square is always a parallelogram. A square is always a quadrilateral. an isosceles trapezoid is always a quadrilateral. If you move up the diagram, the answer is always. If you move down the diagram, the answer is sometimes. A quadrilateral is sometimes an isosceles trapezoid. A quadrilateral is sometimes a square. A rhombus is sometimes a square. Quadrilateral is sometimes a kite. So if you move down, it's sometimes. If you try to move side to side between families, the answer is never. A trapezoid is never a square. You can never have one pair and two pairs of parallel sides at the same time. A kite is never a trapezoid. So moving within the families, or to a different family I should say, is a never. The only unique one that might show up that we would really want to look out for is a rhombus is sometimes a rectangle. And that is when it's a square. If I tell you it's a rhombus, it might be a rectangle also, because a square is both. So that's the only unique one. A couple quick examples and we're done. So here's the first example. JTKB is a kite. And we want to solve for x and y. In this case, we just use the definition. These two sides are congruent to each other. So 2y plus 5 equals x plus 6. Doesn't do anything for me. I've got x and I've got y. But there's another pair. 2x plus 4 is equal to 3x minus 5. This one I can solve. I can solve for x by subtracting 2x and adding 5 to both sides. So we can subtract 2x, add 5, and we've got 9 equals x. I have solved for x, so I will now substitute into this equation 2y plus 5 equals 9 plus 6. 2y plus 5 equals 15. Subtract 5 from both sides. 2y equals 10. And now we divide by 2 and we get y equals 5. So my two answers are y equals 5 and x equals 9. In this case, the sides were marked for us because they have to be. In order to be a kite, we have to have two pairs of adjacent sides congruent. We have to be told which two pairs they are. Simple definition combined with solving. Last question. Given rhombus LUKE, we're going to solve for x and y. Now in this case, the key is the word rhombus. Equilateral, quadrilateral. All four sides are congruent. So 3y minus 2 is equal to 2x plus y, which is equal to 3x plus 1, which is equal to 5x minus 5. All four of them are equal, so we get to choose whichever ones we want. Don't choose the one with x and y. And then these two right here have x, so let's get rid of the one that has y. 3x plus 1 equals 5x minus 5. Subtract 3x from both sides while we add 5 to both sides. And we get 6 equals 2x. Divide by 2, and we've got 3 equals x. Now that we solve for x, we can plug it into whichever one we want. 3 times 3 plus 1 equals 10. Every side in this shape has a side length of 10. Well, I'm not going to use the one with x and y. I'll use the one with just y. 3y minus 2 has to equal 10, because every single side equals 10. Add 2, 3y equals 12, and we get y equals 4. So we have x equals 3, y equals 4. Those are the values that x and y have to be if this is a rhombus. They tell us it's a rhombus, so therefore these are the solutions. That's it for Chapter 6, Section 1. You can now start on assignment number 1.